This exercise is going to have us do something very similar to what you've seen already with Fibonacci. So we are going to build, we're going to use a mathematical series, okay? And we're going to build a little program that is able to give us the nth element of that mathematical series, okay? So in our case, the mathematical series that we're talking about is defined here. I'm going to cut and paste it in the code as a command, okay? Is defined as follow, okay? So we are going to define a method m, and that method m returns for an index I the sum of 1 plus 1/2 plus 2/3 plus and so on and so forth, plus pretty much I divided by I plus 1, okay? So that's pretty much what we're trying to implement in this. I mean, the class is just there to stand and give us a class pretty much to write our code in, okay? But really what we want to write is a recursive method that is going to compute that series. And then at the added bonus, if you want to call it that, the requirement asks us to write a program that is going to display actually the value of m index I, or m of I, sorry, I should say, for I equal 1, 2, 3, up to 10. Okay, so let's start with this. All right, we are going to assume we have a function, a method m somewhere. So if we want to go over, different value for the parameter, that's clearly an iteration, a counter-controlled loop, okay? So I equal 1, I lesser equal to 10. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I plus plus. And inside that loop, all I have to do is system.out.println. And I'm going to display the result of calling the method m, which I didn't write yet, on a parameter value I. Okay, so if I try to compile this, obviously it's not going to be really happy. So I'm going to do a public static void, public static double m int I. Okay, I'm going to return potentially a floating point number. So now that I have this, I could do, just for the sake of testing my program, return 0, and now I can compile. So it's a good idea, to stop here and make sure that we have something that kind of works already. So 1, 2, 3, 4, 5, 6, 7, and then I'm scrolling some more, 8, 9, 10. Okay, so I double check that, yes, I display 10 results. All right, so all those results are 0, that's okay, it's because my implementation so far is not really doing anything useful. So, now back to the meat of the problem, which is the recursive aspect, okay? So we want to start always when we define a recursive method with the stop case, end case, okay? When do we need to stop the recursion? Well, in this case, if I equal 1, okay, I can actually stop right there. I can say I return 1. So that's going to allow me to actually handle the first value, right, in my series. Else, so that's my only stop case. Fibonacci has 2 stop cases. This function has only 1 by its definition. Else, I'm going to return the result of a recursive call. So m called on parameter, not nm, sorry about that. M called on parameter I minus 1. Okay, so that's my recursive call. But I'm going to do something with that recursive call. Okay, I'm going to add 1 divided by I. All right, so let's compile this. Let's run this. Okay, and here are the results. So it's not really nice to double check because there are a lot of decimals and stuff like that, but I'm going to leave that on half of the screen so that you can compare with what you are getting in your version, okay? But the interesting part is not the method itself. We could compute just about anything we want here. It doesn't matter, okay? For the sake of the exercise, the only thing that matters is that you get used to taking a recursive definition of a function, or a definition that is given to you exhaustively by listing actually the sum that's going to be computed, and transform that into a recursive Java method. Okay, so that's really what you need to practice.